Dear students, so in previous class we were discussing about the uniform convergence and the non-uniform convergence of some functions. So now let us consider another function. Let f of x equals x square. Consider a function f of x equals x square where x falling closed, open, 0, infinity. Check whether the function is uniformly continuous or not. In this domain, x falling, closed interval, or closed, open, 0, infinity. So how? So for consider function, consider letter xn. So you can xn equals root n plus 1 and yn equals root n. Consider xn equals root n plus 1 and yn equals root n. So clearly this sequence xn or such xn is a part of this. Suppose it is a. So clearly xn is a part of a and also sequence yn is also a part of a itself. Clear? Now what about the limit xn minus yn? Limit xn minus yn equals limit, what is xn? Xn equals root n plus 1 minus root n. Limit root n plus 1 minus root n, so that equals limit. Then how to find out the limit of root n plus 1 minus root n? So it is root n plus 1 minus root n into root n plus 1 plus root n all divided by root n plus 1 plus root n. Okay, so that equals, which is limit a plus b into a minus b, which is a square minus b square. So it is n plus 1 minus n, so it is 1 divided by root n plus 1 plus root n. So limit n tends to infinity of this one is nothing but 0 itself. Okay, that means that is limit xn minus yn equals 0. Agreed. Again, what is f of xn? Modulus of f of xn minus f of yn. Modulus of f of xn minus f of yn equals, what is f of x? X square. So it is modulus of f of xn. What is xn? Root n plus 1. So root n plus 1 whole square means n plus 1 minus n equals 1. That means modulus of f of xn minus f of yn does not converge to 0, means it is greater than epsilon. Okay, why? Because it is converges to 1, so limiting value is 1, so it is does not converge to 0, means it is greater than 0 epsilon. So by the criteria for non-uniformity, limit xn minus yn equals 0, but modulus of f of xn minus f of yn greater than epsilon, so that means the given function f is not uniformly continuous. Agreed. So the function is not uniformly continuous. F of x equals x square is not uniformly continuous on the given domain closed 0 infinity. Agreed. Now you can consider another function. Suppose f of x equals, what about the uniform convergence, uniform continuity of f of x equals sin 1 by x. Consider this one, sin 1 by x, where x falling open interval 0 infinity. What about the uniform continuity? Is it uniformly continuous or not uniformly continuous? Under where f of x equals sin 1 by x, where x falling open interval or x falling 0 infinity. How? You can define letter xn and yn presents in B such that xn equals 1 by, define xn in such a way that xn equals 1 by pi by 2 plus 2n pi. Surely this 1 by pi by 2 plus 2n pi presents in where? This interval. Clear? Okay, we may choose this yn. Yn equals 1 by 2n pi. This 1 by 2n pi also fall in B itself. Agree? Then what about limit xn minus yn? Limit xn minus yn equals limit of 1 by pi by 2 plus 2n pi minus 1 by 2n pi. Okay, so what it is? It equals limit 1 by pi by 2 plus 2n pi minus limit 2n pi. So it is always equals 0 itself. Clear? But what about the modulus of f of xn minus f of yn? Modulus of f of xn minus f of yn equals modulus of what is f of x? Sin 1 by x. So it is sin 1 by xn. What is 1 by xn? 1 by xn means 1 by 1 by. So goes to the numerator. Sin pi by 2 plus 2n pi minus f of yn. It is sin 1 by 2n, 1 by 1 by 2n pi. So it is 2n pi. F of x equals sin 1 by x. Xn is 1 by pi by 2 plus 2n pi. So f of xn equals sin 1 by xn. That is sin pi by 2 plus 2n pi. Agreed? Equals modulus of what is sin pi by 2 plus theta. Sin pi by 2 plus theta is cos theta. That is in second quadrant. So it is cos 2n pi minus sin 2n pi. That equals cos 2n pi minus sin 2n pi. Sin 2n pi is 0. Cos 2n pi is 1. So that means when limit of xn minus yn equals 0, even limit xn minus yn equals 0, modulus of f of xn minus f of yn does not converge to 0. That means it is greater than epsilon. So by the criteria of non-uniform continuity, the given function f of x equals sin 1 by x in the given domain should be not uniformly continuous. Okay. So now check whether what about the continuity or the uniform continuity of a function f of x equals 1 by 1 plus x square in a real line. F of x equals 1 by 1 plus x square in a real line or on R. Do you say that this function is continuous uniformly or not? So we may consider, as usual, here f of x equals 1 by 1 plus x square. So what about the modulus of f of x minus f of y? Modulus of f of x minus f of y. So modulus of f of x minus f of y is modulus of 1 by 1 plus x square minus 1 by 1 plus y square. Okay. Equals modulus of 1 by 1 plus x square minus 1 by 1 plus y square. You can take the LCM. So it is 1 plus y square minus 1 plus x square. So numerator is y square minus x square divided by the same denominator. What is the denominator? 1 plus x square into 1 plus y square. Whatever. So this can be rewritten as modulus of y square minus x square divided by 1 plus x square into 1 plus y square. Okay. But what is y square minus x square? Modulus of y square minus x square is modulus of x square minus y square. That can be rewritten as modulus of x minus y into modulus of x plus y divided by 1 plus x square into modulus of 1 plus x square into modulus of 1 plus y square. Okay. But we have modulus of x plus y. Mod x plus y less than or equals mod x plus mod y. Okay. According to that argument, which is less than or equals modulus of x minus y into, it is mod x plus mod y by 1 plus x square into 1 plus y square. Okay. Which equals modulus of x minus y into mod x by it is 1 plus x square into 1 plus y square. So it is mod x by this denominator plus mod y by this denominator. mod x by mod 1 plus x square into mod 1 plus y square plus mod y by mod 1 plus x square into mod 1 plus y square. Okay. But consider, what about the mod x by 1 plus mod x square or 1 plus x square? Mod x by 1 plus x square always, mod x by 1 plus x square always less than 1. That is true for every x in R. For any real number R, we have mod x by 1 plus x square strictly less than 1. Okay. Similarly, mod y by 1 plus y square or mod y square strictly less than 1 for all y falling R. Clear? So it is mod x by, it is less than or equals modulus of x minus y into mod x by this one plus mod y by that denominator. Means it is modulus of f of x, that means modulus of f of x minus f of y less than or equals modulus of x minus y into, it is mod x by this one, mod x by 1 plus x square 1 plus y square into mod y by 1 plus x square into 1 plus y square. Okay, that, but mod x by 1 plus x square less than 1. Mod y by 1 plus y square also less than 1. So for, or mod x plus mod y, or sorry, mod x by 1 plus x square plus mod y by 1 plus y square strictly less than 2. Okay, so it is finally, it is less than or equals modulus of x minus y into 2 into 1 plus x square plus mod y by 2 into 1 plus y square. Okay, so that means it is, but mod x by 1 plus x square less than 1, mod y by 1 plus y square less than 1, so it is less than or equals modulus of x minus y. So finally, modulus of f of x minus f of y less than or equals modulus of x minus y means this f satisfies Lipschitz condition, or f is a Lipschitz function. F satisfies Lipschitz condition with the Lipschitz constants k equals 1. So we know that when a function is satisfies Lipschitz condition, or if f is a Lipschitz function, then f should be uniformly continuous. If any function satisfies Lipschitz condition, that function is always uniformly continuous in the given domain. So according to that argument, f of x equals 1 by 1 plus x square for all x fall in R. We already say that f of x is a Lipschitz function with the Lipschitz constant 1. Hence, clearly this f is uniformly continuous. Okay, so f of x equals 1 by 1 plus x square is a uniformly continuous function on the real line. Clear? What about this function? F of x equals sin x. Is it uniformly continuous on R? Now check whether the uniform continuity of the another function f of x equals sin x on real line. How? So for, again you can consider, for checking the, so to prove the uniform continuity, we may first consider modulus of f of x minus f of y. What is the nature of this modulus of f of x minus f of y? That's the crucial point. So f of x equals sin x on this real line. Consider modulus of f of x minus f of y. What is it? It is modulus of sin x minus sin y. Okay. So it's of the form sin c minus sin d. What is sin c minus sin d? It is 2 cos c plus d by 2. Means 2 cos x plus y by 2 into sin x minus y by 2. So modulus of 2 cos x plus y by 2 into sin x minus y by 2. Okay. So which is less than or equals 2 into modulus of cos x plus y by 2 into modulus of sin x minus y by 2. But we know that. What about the modulus of cos theta? Mod cos theta less than or equals 1. So it is less than or equals 2 into Mod cos theta less than or equals 1. So means modulus of cos x plus y by 2 less than or equals 1. So 2 into 1 into modulus of sin x minus y by 2. But we also know that modulus of sin x, mod sin x less than or equals x. Mod sin x less than or equals mod x. Why mod cos x less than or equals 1? You can integrate cos x, you can integrate, means minus 1 less than or equals cos x. We know that mod cos theta less than or equals 1 means minus 1 less than or equals cos theta less than or equals 1. If you integrate with respect to theta, then minus theta less than or equals sin theta less than or equals theta. Okay, so means modulus of sin theta less than or equals mod theta. So mod sin x less than or equals mod x. So it is less than or equals 2 into modulus of x minus y by 2. So that means modulus of f of x minus f of y less than or equals modulus of x minus y. So clearly the f of x equals sin x is a Lipschitz condition with the Lipschitz constant k is 1. So f satisfies the Lipschitz condition. Thus we know that f is a uniform continuous function. Why? Because it satisfies the Lipschitz condition, or f is a Lipschitz function. Agree? Now, suppose f and g are uniformly continuous. Let f and g are uniformly continuous. What about f plus g? Do you say that f plus g is uniformly continuous? Sister, another such. If f and g are uniformly continuous on any domain, then what about this f plus g? Do you say that this f plus g is uniformly continuous? So, come to the proof. F and g are uniformly continuous on E means let epsilon is positive, there exists delta positive, such that f and g are uniformly continuous means f is uniformly continuous means modulus of f of x minus f of y strictly less than some some epsilon, or strictly less than some epsilon by 2, provided modulus of x minus y strictly less than delta 1. Okay. Again, g is uniformly continuous on E. G is uniformly continuous on A means modulus of g of x minus g of y strictly less than some epsilon by 2, provided modulus of x minus y less than delta 2. Agree? So put delta equals minimum delta 1 delta 2. So these two equations are held for this delta. That means mod f of x minus f of y strictly less than epsilon by 2, provided mod x minus y less than delta. Mod g of x minus g of y less than epsilon by 2, provided mod x minus y less than delta. Therefore, if mod x minus y less than delta, then consider modulus of f of x plus g of x minus f of y minus g of y. So it equals modulus of f of x minus f of y plus g of x minus g of y. By the property, it is less than or equals modulus of f of x minus f of y plus modulus of g of x minus g of y. But for when mod x minus y less than delta, we know that mod f of x minus f of y less than epsilon by 2 as well as mod g of x minus g of y less than epsilon by 2. So it is strictly less than epsilon by 2 plus epsilon by 2 equals epsilon. That means if modulus of f of x plus g of x minus of f of y plus g of y strictly less than epsilon, provided mod x minus y less than delta, so that means f plus g is uniformly continuous. So when f and g are uniformly continuous on a given domain, then the sum of the function f plus g is also uniformly continuous on the same domain. So that's an important result. That is, if any two functions are uniformly continuous on a given domain, then sum of that two functions are also uniformly continuous on the same domain. So that result is so important. Thank you.